Welcome back. This is video 4, continuing our work to get ready for our final exam here in Math 109. So we're going to begin, I believe we left off at 26, so we'll start this one at 27. So let's get the visualizer fired up. We'll move forward. Okay. 27, students in Mrs. Smith's class were divided into 10 teams with 12 on a team. That's 120 students total. Oh, I got to change my answers. Hold on. That was cute. There we go. So we know that there are 120 students, that's 10 times 12, and they're going to be busted up so that now we're going to form teams of 15. So we'll take 15 and divide into 120, and we'll find that we can have 8 such teams. So that's cool, Rob. The next one I think sometimes seems difficult for kids. You want to find numbers, if you can, that are divisible by 10 with a remainder of 2. So I just made a list of them. All right, so 12 is one of those such numbers. So is 22. So it's 32, 42, 52. You also want the number to be able to be divisible by 15 with a remainder of also 2. So 17 would be one such number, so it would be 32, so it would be 47. So you're saying, are there numbers that are in both of those lists? Yeah, it looks like 32 is. For that matter, so is 62. If you're really going to go bonus, so is 92. So you only needed to find one. Didn't have to go too far. Don't overthink this. In a sense, you get your first number by just adding the 10 and the 2. There's 12. And then you get your next number by adding 10 more. And then add 10 more. And then add 10 more. On the bottom list, you get your first number by adding the 15 and the 2. And then you get your next number by adding 15 more. And then add 15 more. So then you basically run that list until you try to find a number that's in both of those lists as you find 32 or 62 or 92. Okay. 29. Question says, which of those operations is done last? All right, so this is your order of operations or PEMDAS. So the parenthesis stuff has to be done first. The grouping is done first. So that means the minus and the plus are first priorities. So that means the last thing to be done would be the divide. All right, that was fun. 30. Chance to do some lattice multiplication. I went ahead and set up everything. You're multiplying 138 by 428. And in each case, you simply multiply. So 8 times 4 is 32. 3 goes to the top box, 2 to the bottom box. 8 times 2 is 16. 1 to the top box, 6 to the bottom box, and so on. Remember, when you add the diagonals, be careful, because if you get a sum of 10 or more, there'll be a carry over to the next diagonal. So the first diagonal added for a 4. Then I added 6 and 6 and 4, and I got 16. So I recorded the 6 and carried that little itty bitty 1. See kind of up there in that middle diagonal. So I'm going to add 1 and 2 and 1 and 6 and 2 and 8. You guessed it, that's 20. So I recorded the 0, carried the little 2 up to the next diagonal. So be careful on the carries on your lattice multiplication. Get your answer by making that L, so it's 59,064. Correct answer for lattice multiplication. Next problem says, see what you can do, get me to 1 power. So the first one's kind of nice because your bases are all 6. So when you multiply, you get to add powers. When you divide, you get to subtract powers. So your arithmetic is an add of 12, and it looks like 15, and then a subtract of 20. So 27 minus 20 is 7. So the answer is 6 to the 7th. Next one's a little sneaky in that you need to change your bases. So I took everything to 2's. 4 is 2 squared. 8 is 2 to the 3rd, and 16 is 2 to the 4th. So you see the 4 changing out. Just don't lose those outside powers. So you're going to have to do 2 to the 2nd to the 6th. That's your chance to multiply those powers. That's how we got to 2 to the 12th. Same idea on 2 to the 3rd to the 4th. Again, multiplying the 3 and the 4. That's how the 12 got there. And last but not least, 2 to the 4th to the 2nd is 2 to the 8th. Multiplying 4 times 2. Last step is adding the powers, and gets us 2 to the 32 for our final answer on 31. New answers. 32, word problem, baby. All right, Dan's got pennies and he puts them in boxes. There are 3 boxes. And he says there are 3 times as many in the first box as the third box. So I put X to represent how many were in the third box. It makes the first box be 3X. Be careful in box 2. It says box 2 has twice as many as the first box. So box 2 is 2 times 3x, that's 6x. It's not a hard problem once you get to that. You add up 3x, 6x, and x, and you got to get a total of 4520. It's a lot of pennies, man. So we're going to add them all, get 10x at 4520, and that means x is 452. Then you got to go back and just use that number to find out how many pennies are in each box. Box 3 has 452. You know what? I just realized my answers are written backwards. Box 3 has 452. Box 1 has 3 times that, which is the 1356. Box 2 is correct at 2712. So my answers have the wrong guy for box 1 and the wrong guy for box 3. The numbers are correct, but the values in boxes 1 and 3 should be reversed. Okay. Moving into chapter 4, this is content from unit 5 for us. Okay, so first that's true, false. Part A says 6 is a factor of 30. That is true. Part B says 7 divides 12. That's false. 7 divides 7. 7 will divide 14, but it doesn't divide 12. Part C says 44 is a multiple of 22. That's true. Part D says 6 is a divisor of 12. That's true. Part E says 240 is a multiple of 4. That's true. Part F says 5 does not divide 15. That's false. 5 does divide 15 3 times. All right, divisibility tests for 34A and B. 34A says if 9 people are on each team and you've got 1388, will some teams not have the same number of players? So it's just a matter of, does 9 divide that? Sadly, it does not divide evenly, so some teams will have more or less players than another. Part B, farmer in the Dell, 44,856 potato plants. He wants to plant in 4 long rows. So the question is, will there be an even number of rows or an even number in each row? So does 4 divide prettily into 44,856? I said, yes, it does. All right, 35 says, without using a calculator, try to decide whether 21448 is divisible by these guys. All right, so first of all, it's divisible by 2 because it's even. It's divisible by 4 because the last 2 digits, 48, are divisible by 4. It's divisible by 8 because the last 3 digits, 448, is divisible by 8. It's not divisible by anything else. You see, I tried to figure out whether 3 would work. I added the digits, so I got 19. And since 3 won't divide 19, 3 won't divide the number. Kind of the same line of logic for divisibility by 9. So the only numbers that will divide prettily are 2, 4, and 8. That's number 35. 36 says fill in the blank with the largest. Oh, gotta get some new answers. Fill in the blank with the largest digit that you can to make this a true statement. Oops. All right, you need 4 to divide into this number. So you look at your last 2 digits, a 4 and the mystery guy. The 4 has to divide that 2-digit number. And the biggest I could create would be if you let me put 8 in that block. So 4 divides 48. So my mystery digit would have to be an 8. Part B, I'd like 3 to divide. So what I did is I added the digits that were already there. I added the 9 and the 6 and the 2, and that's 17. So if 3 is going to be divisible, then 3 has to divide the sum of those digits. So I think if you let me put 7 in there, the sum of the digits becomes 24. Since 3 divides 24, 3 will divide the number 9627. So my mystery digit is a 7. Okay. Next one I kind of like. Put all the digits in the mystery box so that you are divisible by 2. Well, in part A, since the number ends in a 2, doesn't matter what's in the mystery box. Anything can fit because your last digit's even. So 2 will divide the number. All right, for divisibility by 3, you can see that I summed the digits that were there, and I got 19. So I can put numbers in there that I could add to 19 and get answers that are divisible by 3. So I could put a 2 in, because 19 plus 2 would be 21. That's divisible by 3. I could put a 5 in. That would be a sum of 24. That's divisible by 3. I could put an 8 in. That will get me a 27. That's divisible by 3. So the mystery box would have a 2 or a 5 or an 8. Part C, I need to make this thing divide by 4. So again, those last two digits have to be divisible by 4. That means I could have a 1. 12 is divisible by 4. I could have a 3. 32 is divisible by 4. I have a 5. 52. You realize that in each case, I'm just increasing by what would be the effect of 20. So I could have a 1, a 3, a 5, a 7, and a 9. Part D, I need 5 to divide. Sorry, man. You can't put anything in the mystery box because it ends in a 2. And if it's going to be divisible by 5, it would have to end in a 5 or a 0. So I got nothing to offer you on that guy. All right, last but not least, on 8, the last 3 digits must be divisible by 8. And that would be the case if you put a 3 in, because 432 is divisible by 8, as is 472. So the options are a 3 or a 7. I think we're going to shut this video down. We'll come back and pick up our next video as we move past number 37. So we'll be back in a moment. See you then. More.